Welcome to Programming Problems, Episode 2. Today we will be looking at cutting the necklace from Kattis. Let's dive right in. The abridged version of the problem description goes as follows. A group of friends was given a necklace. The necklace is a circular wire with golden beads of various weights. They want to cut the wire into segments so that everybody gets one segment, gets the same amount of gold. No bead is cut or split in parts, and no beads are left over after dividing them. Given a necklace, we are to find if such a split is possible. Now for the inputs and constraints. We will be given the number of friends, K, which shall be at most 1 million. Additionally, we will be getting the total number of beads in the necklace. There can be at most 10 million. Finally, for every bead we will get the weight. The weight of a single bead can be as large as 1 billion. Note that whatever solution we will come up with, we will need to process or inspect every single bead at least once. So these numbers put a bit of a restriction on what kinds of solutions shall be fast enough when solving this problem. But before we dive into that, let's look at and understand the examples. In the first example, we are given 3 friends, which have to divide 4 beads among themselves. The necklace is given to us as beads of weights, 1, 2, 2, and 1. It is shown visually on the right. Now, can this necklace be split up into 3 segments of equal weight? Well, the necklace is really small, so after looking at the bead values and playing around with making segments a bit, you too will find that this is possible. The solution here is to give one friend the pair of beads with value 1 each, and 2 friends will each get a single bead of value 2. Now for example 2. We are presented the same number of friends and beads, but the beads themselves have different weights. Is making a split possible this time? We can see that our largest bead has value 4. If we reason about this, then because every friend must have at least 1 bead, this means that every friend also must end up with a value of 4 or greater. We could give one of the friends the bead of value 4 and another friend the segment holding 2 beads of value 2. Unfortunately, there is not enough value in the necklace to then also give enough value to the last friend. Because we are not allowed to split beads, we thus have to conclude that it is not possible to divide this necklace according to the rules. But hopefully these examples have already given you some insights. Let's look at the things we can infer. Let's remind ourselves again that the input is very large. N can be as great as 10 million. Thus, ideally, we do something that is linear, meaning on the order of n, or better. Before finding the correct segments for each person, there are some cases in which it is trivial to determine that a split is not possible. For example, consider that K, the number of friends, is 1. Then that single friend simply gets all the beads and we report yes. Additionally, we know how much weight or value every friend must get and set this as the target. This target is simply the sum of all the bead values divided by K. Therefore, K must be a divisor of the sum. Consequently, this also means that no single bead in our necklace can be larger than this target value. Going back to our constraints, what is something that we can do in order n? Well, we could, for instance, sweep the array once, and while doing so, we can keep track of the running sum. This would allow us to efficiently compute the value of any segment based on the start and end beads. Maybe by now you have already gained some insights which can help you solve the problem on your own. Now is a good moment to pause this video and give it a go. Ready? Let's explore the solution together. We can start with 2 clear steps. In the first step, we try to filter out edge cases for which it is easy to see if it is possible to make the split or not. If after the first step we don't know for sure, we must verify if the correct distribution is possible. Let's look closer at some edge cases. We can give an easy no if K is not a divisor of the sum of the bead values. Similarly, if we compute the target value for each friend, we can check if any bead is larger than this target. If so, then this is again an easy no. Because the problem constraints only give us upper bounds, there are also 2 trivial cases to answer yes. For instance, if n equals 0, then nobody gets any bead, regardless of how many friends there are. And if k equals 1, then all beads simply go to that one friend. Maybe you can find more trivial edge cases, but let's continue to the algorithm. Consider the following necklace with beads of value 3, 2, 2, and so on. We can start out and find, in a single sweep, all possible segments. For these segments, we track the starts and ends. If we are to find a solution, then it shall be a combination of the segments which we find in this step. Let's do it for this example. We start at index 0, which is a bead of value 3. Here we track a pointer for our segment start and an additional pointer for our segment end. Now, assuming we have done the running sum we mentioned earlier, we know the total sum and thereby our target. Additionally, the running sum allows us to find the sum for each segment really fast. Though, optionally, you could also keep track of the value for the current segment simply by updating it while sweeping. I shall demonstrate how. In this example, the target is 4, and our current segment only is 3. So we know we need to expand our segment to see if we can add up to 4. Expanding here simply means we have to move our end pointer by 1 and add the value which we find there. In this case, our segment now equals 5. This is larger than the target, so we subtract the value that is pointed at by our start pointer, and we move the pointer 1 to the right. Now the sum is smaller than the target, so we move our end pointer again. In this case, we find a segment because the sum is 4. It is important to track this segment, for instance in a list where you store pairs of start and end points. Expanding the segment now will for sure lead to the segment being too large, so we move both the start and end point of our segment and continue our algorithm. Of course, we should not forget to add and subtract the values as before when updating our window. The current segment is again too small, so we move the endpoint. Here we find another segment again. We can add this to our list of segments. Following this pattern, we keep going until we found all possible segments in our necklace in linear time. Great! The first step is done. For this example, we end up with the following start and endpoint pairs, which denote all possible segments in this necklace. So essentially, we now reduced the problem to finding whether there is a sequence of these segments which will loop around the necklace perfectly. All that's left to do is looping over all of these segments as a potential start segment. In the cases where there is one or more cycles through this segment list, any of the starting points will already give us our answer. If there is no cycle hidden in here, then we find that we still have reduced the problem enough to get a fast enough result. Let's look at how to do this. We start with the first segment, 1, 2. Then, because the current segment ends with 2, the next segment should start with 3. We find that indeed there is such a segment, 3, 6. By the same logic, we jump to the next segment, 7, 8, and subsequently to 9, 0. After 0 comes 1, and we end up on our initial segment again. We found a loop, thus an assignment is possible, and we respond yes. If we had not found a loop, we would start at the next segment, which is 2, 4. Now the segment that would have to follow should start with a 5. There is no such segment, hence 2, 4 cannot be part of the solution. In this example, however, we already found a solution, and we can visualize it as follows. And that's all there is to it. You now should have the knowledge and insights to write an algorithm which solves this programming problem. Please consider liking and/or subscribing for more content like this. And if you have suggestions for the future or you know a better way to solve this, then do leave a comment below. Thanks for watching.